Hey everyone. So I've received a couple questions about how to complete or how to read um, these moon diagrams on the last 3 pages of this week's lab. Okay. So I thought I'd make a quick video kind of explaining the process and how to think about them. Okay. So each of these on the last 3 pages, there's six on each page, so there are 18 of these diagrams. You can picture an observer, or you, standing on the Earth facing south. Okay, that's why south is written where it is, and thus the eastern horizon is to our left and the western horizon is to our right. Okay. The moon can be pictured anywhere above the horizon or even on the horizon in some cases, and it'll have some phase shown on it. Okay. It's your job to try and determine from the phase and where it is in the sky where the sun is, and thus what time of day it is. Okay, because that's how we determine the time of day, right? From where the sun is in the sky, not from where the moon is. All right, so to start, think of the moon and the sun moving in some arc, right? It's rising in the east and it sets in the west. Whoops. Sets in the west. Okay? So if the sun happens to be anywhere in the eastern half, so eastern or left of this meridian line, if it's over here, well, that's the AM. That's the morning, right? Anti-meridian. If the sun is on the right side of the meridian over here, it's the afternoon, right? It's afternoon, and so we call that PM for post-meridian. So with this in mind, right, this arc in mind, I'm going to take it away. And now let's get to how we actually determine where the heck the sun is, okay? All right, there are a couple steps that you need to determine, and in this specific order. So step one is to look at the moon and determine which side of the moon, left, right, top, or bottom, the sun is, based upon how it looks, right? So we see in this showing, the sun is on the right side because the right side of that moon is lit up. So the sun has to be somewhere over here, okay? That's the first step. So determine where's the sun, right? Top, bottom, left, right. So I'll do that as, up, down, left, or right of the moon, right? We've determined that it's on the right side, somewhere over here in the western hemisphere, because the western side or the right side of that moon is lit up. The next thing you have to take into account is, well, what's the phase of the moon shown? In this case, the exact right half of the face towards the Earth, right, the visible face, is lit up. And so, because just the right half is lit up, we call that first quarter. Right? You might hear it referred to as half moon. That's half correct, right? It's actually first quarter. So, because it's a quarter moon, that clues you in to the fact that the angle between the moon down to that observer and over to the sun has to be a right angle or a 90-degree angle. So the second thing is to determine the phase and the angle. Well, let's put, there we go. What's the angle? Angle between the moon, that observer on the Earth, and the sun. Okay. So if we were to draw a dotted line from the moon down to our observer standing on the Earth, and then a right angle to the right side, right, that was step one, that means that the sun has to be over there, right? It's on the western horizon because we combined the fact that it's on the right half or the western half of the moon, and from the phase name, it has to be at a right angle. So thus it has to be right here. And now we can do the third step, is to determine the time of day. And if the sun is on the western horizon, well, we call that 6 p.m., at least in this lab, right? And that's our answer. So if you watch this video, no one should get this question wrong, right? 6 p.m. You will see other moon phases that are not quite this straightforward, right? You'll see a full moon. Remember from the moon diagram, the full moon, let's do it in black. If we have the Earth there, we have a full moon over here, and so it's all white, and the sun is over, well, let's see, sunlight is over here. Tell you what, let's do, why do it there? I have more space on another slide. So if this Earth is right there, and sunlight's coming in from the right side, right? A full moon is in the opposite direction from the sun, okay? For a new moon, sorry, that's for a full. For a new moon, should be all dark as appearing from the Earth. Let's draw in the shadows. If we're looking from the Earth towards the moon, for a new moon, we're also looking towards the sun. So for new, it's the same part of the sky. For crescents, the moon is actually over here. And it's down here. For some reason, the size of my moon keeps changing. So from the Earth, this angle is, well, it's greater than 0, like it was for the new moon, but it's not quite 90 like what it will be for the quarters over here, right? So it's a small angle, right? So keep that in mind for the crescents. This will be a waxing crescent, and this will be a waning crescent. The quarter moons, right here, this is first quarter, and down here is third quarter. Right? Remember that angle is 90, and that was the same as in our example. 90 degree. Okay. And the last two is the gibbous moon. So this was a waxing gibbous. And down here is a waning gibbous. And so the angle in between the moon, the Earth, and the sun is now greater than 90 degrees. But it's not quite a straight line because it's not quite full. It's somewhere in between those two, right? It's just greater than 90, but less than, say, a straight line, okay? So keep these angles in mind when trying to determine where the sun has to be based upon the moon's position and the phase shown. All right? Thanks for watching.